Hi everyone, and this is our chemistry first class. I'm going to explain the first chapter of this first semester, that is atomic structure. So before enter into the chapter, I'm going to explain or I'm going to introduce some of the introduction and terms and some of the basic concepts of the atomic structure. In ancient times, the human being doesn't know about these atoms and some of the subatomic particles, but they knows only the matter is composed of the some of the small objects or small substances. Those small substances are molecules, and again those molecules are divided into the atoms. So how they named a atom means the atom name is comes from the Greek letter word, that is atomio. Atomio. So this, oh sorry, this is this is oh, atomio. So the atomio means the undivisible or uncuttable. So they think that this is the small object. These small objects can construct the molecules, and these molecules can construct the matter. So nowadays what you are observing around your matters, those matter is composed of the small objects, they think. The ancient people thinks, and the mainly think about the our Indians, ancient Indians and Greeks or Greek philosophers think about these, what I explained in previous seconds. So later on, the theory is they doesn't know about the subatomic particles, only up to atom they knows. So because of the depending upon those atom, the some theory is introduced into some theory is come into the scenario. That theory is Dalton's atomic theory. The theory is Dalton's atomic theory. Dalton's atomic theory. So the Dalton's atomic theory is coming to scenario, and he explained the atom some of the laws. So already you studied law of conservation of mass, law of conservation of energy, and law of conservation of uh, constant composition and multiple proposition. So these three terms, one is law of conservation of mass, and law of constant composition, and law of multiple proportion. Depending upon those laws, he explained the atomic theory. But later on 20th century, so on 20th century, the different experiments is done by the scientist. They explain the topics. What are the topics? First they introduce the electron, proton, and neutron. So these are the some subatomic particles which are present in the atom. So that's why the atom behaves, different atoms behaves differently. But before enter into these subatomic particles, there is some of the experiment is done to find out these subatomic particles. One is electron can be detected by using the discovery of electron by using the discharge tube experiment, that is Thomson model. Sorry, uh, that is J. Thomson find out the discovery of electron by using the discharge tube experiment. He takes the cathode ray tube, that is discharge tube, and they travel the cathode rays from cathode to anode. You know that one. Only I explain the basics because some of the topics are not included in your sem 1. So that's why before entering into the main topic, I want to explain some of the topics to remind you. Okay, so discovery of electron is done by the J. Thomson by using the cathode rays experiment, and later on the determination of charge to mass ratio is also explained by the uh, Thomson by using the same experiment. And later on the electron charge of electron charge of electron is done by the Mulliken oil drop experiment. Mulliken oil drop experiment is done to find out the charge of the electron. And later on, the discovery of the proton is done by using the scientist name is Goldstein. Sorry, wait. Yes, the Goldstein expand find out the proton, that is the discovery of proton is done by the Goldstein. And later on, the neutrons is find out by Chadwick. The scientist name is Chadwick. He discovered the neutron by using the some beryllium experiments. So this is the some of the basics model to find out the subatomic particles which is present in an atom. One is electron, that is discovery of electron is done by the J.J. Thomson, and later on electron charge is done by the Mulliken oil drop experiment, and later on discovery of proton is done by the Goldstein, and the neutrons done by the Chadwick. And later on, after finding these subatomic particles, the scientists are thinks about how the atom is stable, how the atom is stable, because the electron charge is negative and proton charge is positive and neutrons is present. Then where the electron is present, then where the proton is present, then where the neutron is present in the atom. So to find out the atom structure and the atom stability, there is a different models come to explain the atom. That is Thomson model of atom. For the first and foremost explanation for the atom stability is Thomson model. That is also called as watermelon 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 atomic model. So in this watermelon atomic model, the electrons are the seeds, and the the mass which is present in the watermelon, that red color plums, um, the the red color substance which is present in the watermelon shows the remaining mass of the mass of the atom. So the electrons are embedded, it means that the electrons are present in the atom like a seeds in the watermelon. That is Thomson atomic model. The main important point of the Thomson atomic model is they explain the mass they explain the mass of atom. They give the sum of the explanation for the mass of the atom. So that is the done by the Thomson model of atom. And next one is Rutherford atomic model. What is Rutherford atomic model? Rutherford model is, he explained the atomic model by using the alpha ray scattering experiment or alpha particle scattering experiment. Already he take the gold foil and he travels the alpha particles through this. Some of the alpha particles are bound back and some of the alpha particles are traveled, and those can be strike on the some zinc sulfide screen. This is a zinc sulfide screen, and whenever they travels, there is no presence of the any substance in the gold foil. But whenever they bound back means the alpha particles has the positive charge, so that's why they bound back. It means same charges repels, opposite charges is attracts. So that is the sum of the Rutherford's alpha ray scattering or alpha particle scattering experiment. So this is the sum of the basics which is present in the before enter into the main topic. So first you find out the electron, and later on you find out the charge on the electron. Then the scientists are find out in the 19th or 20th century. In 20th century they find out the protons and the neutrons, and later on after finding these basics of the atoms, they find out the Thomson model of atom. So that is a basic atomic structure. That is how the atom is arranged and how the atom is stable by using the Thomson model of atom. Later on, Thomson model does not explain in a clear way. That's why the Rutherford did an experiment by using the alpha particle. He want to explain the structure of the atom, and he explained the nucleus. The alpha particles tells the Rutherford alpha particle experiment can explain the nucleus. Sorry, I'm writing here some of the words are confusing. Don't get confused. Uh, just listen what I said while I'm writing. Okay, thank you. And next, so these are the some of the basic or starting uh, atomic theories. Later on, before enter into the deep discussion about the atomic structure, the atomic structure means the atom, how the atom is arranged, and how you can explain the stability of the atom, and how you can explain the subatomic particles which is present in the atom. So those studying here, you can clearly study the atomic structure. Those subatomic particles are studied in the chapter, in this atomic structure chapter. So before enter into that, we have to learn some of the basics terms, and those basic terms are atomic number. First and foremost of the atomic number. What is atomic number? So the atomic number means the number of protons which is present in the number of protons, the number of protons present in the nucleus is equals to the atomic number. So r r the number of electrons which is present in the present in the atom is also called as present in the atom is also called as atomic number. It is denoted by Z. So the atomic number is denoted by the Z. So for suppose if you are taking the, for example, the number of protons which is present in the hydrogen nucleus is only 1. So before entering into that, nucleus means nucleus consisting of the protons and neutrons. The protons has the positive charge, electron has the negative charge, and neutrons has the neutral charge. That means they does not have any charge. So there is a one term is there before entering into the full chapter, that is atomic number. What is atomic number? The atomic number means the number of protons in the nucleus of an atom, or which is also equals to the number of electrons in a neutral atom. So for suppose if you are taking the hydrogen, the hydrogen the the hydrogen, for example, if you are taking the number of protons which is present in the hydrogen is 1, so the atomic number is 1. For suppose if in a sodium atom, for suppose if you are taking the sodium atom, the sodium atom has 11 protons in the nucleus, or 11 electrons which is present in the sodium, so that's why the atomic number is 11. So whenever the atom is it is neutrally present, the atom is presently neutrally present, that's why it can be show some stability. So if the atom is neutral means they have the equal charges, opposite charges are equal present, that is number of protons which is equals to the number of electrons. So that's why whenever you consider the atomic number, so you either you consider the number of electrons or either you consider the number of protons, so it is denoted by the Z. So that's why the atomic number definition is number of protons in the nucleus of an atom is equals to the number of electrons in the neutral atom. So that is the atomic number. And next one is mass number. Next one is mass number. What is mass number means? The mass. So for suppose if you want to tell the weight of the substance, you can weight, am I right? So weight means it depends on the gravitational force. Weight, mass is different. So but here the mass number means the atomic the atom weight, how much mass is present in the atom means, so which is equals to the sum of the mass number is equals to the sum of the number of protons plus number of neutrons. So this is the mass number. It is denoted by the A. It is denoted by the A. Very very important. The mass number is denoted by A, and the atomic number is denoted by the Z. So The mass number means the number of nucleons. What is nucleons means? Protons plus neutrons is called as nucleons. Nucleons means the protons plus neutrons is called as a nucleons. So A is mass number, which is equals to the protons plus neutrons. So these two are the combined two is called as nucleons. Sorry, new wait. The combined two is called as the combined two is called as atomic number. A is equals to the proton plus neutron. These two is called as nucleons. Nucleons. Protons plus neutrons is called as nucleons because those are present in the nucleus. So the sum of protons plus neutron is called as mass number. A means mass number, right? So this is the explanation for the mass number and atomic number. And later on, so while you are writing the structure of the atom, for suppose if you want to symbolize the atom normal element uh, in the periodic table, you should use some of the notations. For suppose if your element or atom is X, X, and to represent that, the Z is your atomic number, am I right? Atomic number is denoted by Z, and mass number is denoted by A. So while you are writing the element in a periodic table, at the left side superscript is denoted by the mass number, that is A, and the left side subscript is denoted by the atomic number, that is Z. So like this you have to write the element in the while you're writing the normal element. A is your mass number of that element and Z is your atomic number of that element. For suppose if you're taking the hydrogen mass number is 1 and atomic number is also 1. Like this you have to write the element. And if you are taking the sodium is denoted by Na, so its atomic number is 11, mass number is 23. Like this you have to write. Nitrogen, you take nitrogen atomic number is 7 and its mass number is 14. And if you're taking the carbon is C6, carbon 6, atomic number and mass number is 14. Like this you have to write the notation of the elements. And next one is, after writing the notation, so there is some terms is there. So those are the isotopes and isobars, and like this. What is isotopes? What is isotopes means atoms which have the same atomic number. Same atomic number means Z is same, your Z is same, but different mass number. A means mass number, am I right? So A is different and Z is same. Those atoms are called as isotopes. So isotopes means the atoms which have the same atomic number but different mass number. Atomic mass number, A is different but Z is same. So examples are isotopes of hydrogen. Here I am taking, for suppose if your hydrogen is hydrogen isotopes are three. One is protium, that is hydrogen, another name is protium, very very important, keep in mind the protium. And the hydrogen second isotope is deuterium and third isotope is tritium, right? Here very very important, I am explaining, you keep in your mind this diagram. The formula of the isotopes, I already said the element can be denoted. X means here is hydrogen, so this is a hydrogen, am I right? And mass number is right at the uh, top subscript left side, and Z is denoted at the, am I right? Here I am writing the Z means atomic number is here one is there, am I right? So that is a subscript of the left side, and exactly mass number is 1, and number of protons means which is the atomic number, either number of protons or number of electrons or electrons. sorry, electrons. Sorry, number of electrons or number of protons can decide the atomic number, which is both are equal. But the number of neutrons present in a hydrogen is zero. Very, very important. Every time they are asking how many nucleons are present. Only one, because in the nucleus only the one proton is present, neutron is absent. So that's why in hydrogen nucleons are present is only one, and neutrons are zero. Keep in mind. And hydrogen, sorry, deuterium. In deuterium, mass number is 2 and atomic number is 1. And so all are have same atomic number 1 1 1, but different mass numbers. That is A is the superscript of the left side, 1 2 3. So mass number is 1 2 3. Protons are same, but neutrons are different. So hydrogen has 0 neutrons, deuterium has 1 neutron, tritium has 2 neutrons. So the sum of these two is called as mass number. Number of protons plus number of neutrons is called as mass number. So that's why hydrogen have only one proton, not neutron. Deuterium has mass number is 2. How you get the 2? The number of protons plus number of neutrons is 2. So what is mass number? I already said the number of protons and neutrons which is present in the nucleus are collectively known as nucleons. So mass number formula is number of protons plus number of neutrons. So this is the explanation for the isotopes. What is isotopes? The atoms which have the identical mass number but different, same atomic number but different mass numbers. That is isotopes. And next one is isobars. What is isobars means? Exactly what I said in previous, that is opposite here. What is isobars means? The isobars are the atoms which have the same mass number. Now A is same. Now A means mass number is same, but different atomic number. Here Z is different. Bars is, in isobars Z is different. In isotopes A is different. Keep in mind. So what is isobars? Isobars means the atoms which have the same mass number but different atomic numbers. That is example, you take the C14, sorry, C14 and 7. Here 7 is atomic number and 14 is the mass number. You take nitrogen. Sorry, C6. Sorry, sir, C6. And nitrogen is 7 and mass number is 14. So which have the 14 14. It means carbon and nitrogen have the same mass number but different atomic number. So that's why these two are called as isobars. Isobars. And another examples are argon, potassium. They have both have the 40 40 mass number but different 18 19 is the atomic numbers. And carbon is also 40 20 are typical some of the examples. Each of these have the same mass number. All are have same mass number, 40 40 40. Top left superscript, sorry. And but different atomic numbers. Z is different. So that's why these are called as isobars. Mainly the chemical properties of the all the elements only depends on the isotopes. So whenever you study the chemical properties, it decides by the isotopes only. Isotopes only. So this is uh, the some of the introduction and some main topics into the chapter. These are the some pavement to the increase your basic knowledge of the atomic structure. I think all of you know already these topics, but again I am repeating to uh, to regain your knowledge. Okay, thank you. And next class I am going to enter into the uh, if you have the book, you see the 1.3. That is the what are the main uh, thinking of the Bohr's to explain the Bohr's atomic model. What are the main basics concepts he learned and explained the atomic structure, the main atomic structure of the atom. Thank you. Thank you very much.